What should I do to make the bubble increase? Okay, so some people suggested making the air in here hotter to help expand the balloon. So a good way to do that might be to introduce this into a hot water bath. So what I have over here is some nice water. You can tell that it is hot, like that. So I'm going to bring this closer into view and we're going to put the mason jar in and see what will happen to it. Okay, so here's the container in the hot water bath. I sped up the time a little bit so you don't have to wait as long. But here you can see the molecules, the air molecules, are gaining energy from the collisions of the hot water against the container, right? Then through the glass heating up the molecules in the jar, the air molecules begin to pound against the surface and the surface expands, making a larger volume at pretty much a constant pressure, right? Pressure of the atmosphere. So let me take the container out and I'll put it on the table so that you can see it better. Look at that. Nice increased volume, sealed number of particles, good to go. The question is, what would a graph of pressure versus volume look like for the system that we just made? In case you wanted to know, the lid is quite firm. You can poke at it. And it's interesting to look at the beginning of the video. That's the lid. Let's think about what a PV diagram of the expansion would look like. So here we have the initial state, right? A P naught, V naught. Now, what did we do? We allowed the volume to expand. And we can do that in a variety of different ways. Let's think about what we did with the pressure. We left the atmosphere to apply pressure, so we haven't changed that. So we went from our initial state to our final state without changing pressure, only changing the volume. Initial, final. What happens to the temperature? Well, here's an example of an isotherm, a curve that remains a constant temperature, meaning that as P goes up, V goes down, or like a hyperbolic function. Here would be another one. Which temperature is higher? Well, which PV times PV multiplication is higher, right? This top one. So we have gone to a higher temperature because we went from a P naught, V naught to a P naught, same P naught, but a V final, which is bigger. Right, and this is smaller. And remember that these quantities equal N, which remained constant because we sealed it, times a constant number times the temperature, which you know we increased by putting our sample in a hot water bath. This is isobaric, or constant pressure.